Assalamualaikum warahmatullahi wabarakatuh. My name is Tuan Nurin Nabila binti Tuan Muhammad SUZANI and my supervisor name is Dr. SALWA binti MAHMOOD. Today I would like to present my project, which is multi-criteria decision analysis and CDA for end of life of thermoplastic 3D printing. So the content that I will present today is introduction, literature review and methodology. Okay, for the background of studies, 3D printing, or also known as additive manufacturing, in the late of 20th century is increasingly used by the manufacturer. Nowadays, 3D printing are widely used in many production industries in the world. The technique of 3D printing was developed through the layer-by-layer construction of 3D structures, starting with computer-aided design (CAD) drawing to the 3D printers. One of the best things about 3D printing is the variety of materials that can be used, like polymers, composite, metal and ceramic, and the most common material used is plastic. Plastic is a polymer. So despite being very practical, plastic could present several environmental risks. Product waste frequently end up in landfill or the ocean due to the insufficient infrastructure and lack of recycling option, significantly polluting the environment. So the problem statement is the amount of solid waste in landfills has increased because of people's lack of option and knowledge regarding how to properly dispose of their waste when a product reaches the end of its useful life. People nowadays always throw away the useful or defected product without knowing the right way to dispose the waste properly. There are many research about end-of-life option. However, there is no research paper about the end-of-life option for the waste of 3D printing thermoplastic material. Until now, there is several methodologies that have been developed for decision analysis regarding solid waste of 3D printing related. The next one is objective project. So there is objective that we need to achieve for this project. The first one is to develop methodology to determine the best end-of-life option for a 3D printing product, which is acrylonitrile butadiene citrine or ABS, polylactic acid PLA, and polyether ether ketone P. To recommend the suitable way to dispose the 3D printing waste product based on methodology proposed. The next one is project scope. End of life of 3D printing material, especially for ABS, PLA, and PIC materials. So these three materials that stated I have studied. Second one is conducted by using analysis hierarchy process or AHP method to choose the best option for the end of life of these three materials of 3D printing. And this project conducted at University Tun Husinon Malaysia campus Pago. Okay, product EOL. What is end of life? Okay, end of life is the final stage of the products when it has reached the end of its useful life in the consumer and manufacturer perspective. There are several factors to assume that the product reached its end of life. Okay, the first one is technological advancement. Newer technologies can make existing product obsolete by offering improved features, performance, or efficiency. Manufacturers may discontinue older products to focus on developing and promoting newer innovations. Second is market demand. If a product sale declines significantly or if there is limited demand, the manufacturer may decide to discontinue it. Next is component availability. Sometimes, certain component or part required for manufacturing a product become unavailable or too expensive. Regulatory changes. Changes in regulations or standard can render the product non-compliant or out-to-date. Manufacturers may choose to end production rather than investing and redesigning the product to meet new requirements. And the last one is product life cycle. When a product reaches the deadline phase, sales and profitability diminish, making it less valuable for the manufacturer to continue production. Okay, next, end of life option. So there are several types of method that we can choose to dispose the product. So the first one is landfill disposal. This method is the common one, and this method is the most simple and economical option since the natural decomposition occur at the disposal site. Next is incineration. Okay, waste incineration, also known as burning of the garbage, that use the specialized incinerators to burn the product waste into ash, heat and flue gas. But this option do not suitable for all product waste. The next one is recycling. Recycling helps to protect the environment and use less energy to produce new material. Some materials can even be recycled continuously, making it a popular and efficient waste disposal option. Reuse. The operation or process that use again the old product or components that is still in good condition to create the product with the same function as they were have. And the last one is manufacturing. This option described by the process that using the old products to be cleaned, disassembled, repaired, and refurbished to create the new product or equipment. Okay, MCDA method. MCDA method is the method that I have used to choose the best option for end of life of 3D printing material. So what is MCDA method? MCDA, or multi-criteria decision analysis, is a systematic theoretical way to performing a comparative study of several options that compete based on how well each perform compared to various in order to choose the best alternative for decision making. Okay, here are the 7 general steps to support the decision making. Okay, first one, we need to identifying the problem issue. So we need to identify the objective and the goals to achieve and discuss the decision problems. Next, identify criteria to choose the element that apply to the decision making issue. And next, weight the criteria. So each criteria must have the weight value. For the evaluate alternative, we need to compare all options to the listed criteria. Next, aggregation of criteria to create the overall value or score for each possibility. Next, sensitivity analysis, determine the relevance of the result, and the last one is make the decision to decide and select the best option. Okay, in an MCDA method, there are many methods, and I choose AHP method. AHP method, or analysis hierarchy process, is the most used method applied in MCDA. It is used to create ratio scales from pair comparison that are continuous or discrete. The comparison based on the actual measurement of or a fundamental scale or weight that indicates the difference between the criteria. In order to create or approximate weight, the AHP approach compares criteria or alternative with respect to the criterion, pair with method, and related eigenvector. Okay, next is 3D printing material. This is the material that I have mentioned before. The first one is ABS. ABS filament is one of the best material for 3D printing since the material have the high range of use and application nowadays. ABS has higher tensile, impact and flexural strength than the other materials. In addition to being recyclable, ABS material creates less waste than certain other plastic, making it better for the environment. Okay, the industry that use ABS include pipes and fitting, automotive, household appliance. Next is polylactic acid, PLA. PLA materials have created by green renewable sources like starch, corn, and sugarcane. PLA are more recyclable, and these materials are more environmentally friendly than the other material. These materials are perfect for prototyping industries. So the industry that use PLA include food packaging, automotive, and house appliance. Next is polyether ether ketone or PEEK. So PEEK is a semi-crystalline high temperature thermoplastic. It is an organic thermoplastic polymer that is colorless and produces some of the best outcomes of any thermoplastic on the planet. Typically, PEEK material always used in a lot of applications that require to stand the extreme temperature, plus this material can handle corrosive fluid gases and high pressure. PEEK may have found in many industries such as aerospace, automotive, and medical. Here are some previous research from MCDA method. First one from Ulla et al. They use AHP method to study about the end of life of higher dry spray iron. So the result shows that 56% of the part have priority to recycle, and 40% of the product weight got remanufactured as its preference. Next, Dispatch et al. They use MAP method, and the result shows the economic assessment criteria were weighed with critical drivers for assessing end-of-life management, which is 42%, followed by environmental 35%, and social 23%. When the weight of environment criteria was changed, the most preferred option also changed, and the most suitable option that they got from the studies are recycling compared to landfill and incineration. For this case, the recycling was divided into two, which is inland and export recycle. Next, from Wang and Kaustad, they use Wexa method. They study about the end of life of printed circuit board, and this paper shows the potential of recycler recovering the product end of life from waste. Most metal like nickel, gold, and palladium shows the high compositional availability, but the result will indicate that investment in recycling technology targeting high yield recovery of precious metal such as aurum, palladium, and argentum, and the best metals like copper, nickel, and aluminium could provide larger profit for a recycler. And Josh et al. Use fuzzy and MCDA method for conceptual design. There are 4 criteria that are considered in this decision-making process, which is profit, ecosystem equality, human health, and resource depletion. This study agrees to choose the recycling as the product option, considering there is no metal option that have the combination of weight and of importance, but the proportion between the recycle options and varies for different criteria weight combination. Next, the previous research paper based on 3D printing materials. Zhao et al. Use a study about PLA materials. The closed-loop mechanical recycling was compared to the landfill and incineration in this study, since these are the two most common methods used to dispose of plastic waste. Based on the finding, recycling PLA only once is the best way to dispose of end-of-life PLA. Landfill is the end-of-life option that have the highest environmental burdens. Next, Canadio et al. They studied about the polymer to compare the environmental impact during the whole life cycle of a product used in the marine industry obtained by 3D printing. And this finding suggested that compared to the other two options using poly, uh, polyamide based on marine plastic waste is more environmentally friendly because it has less of an impact across 11 to the 18 analyzed categories. Okay. Cesaris Mendoza used plastic PLA and La Copo et al. Used stainless steel. So based on the previous research, we can conclude that there's no research study about ABS and PIT material. So our next our project flowchart. For the methodology, we start the project and then we developing the methodology for determining the product end of life option. And next we testing the methodology. If the option was successful, we continue to scoring and waiting the end of life product and starting writing the report to complete the project. Okay, for flowchart of AHP process. So we, like I mentioned before, we use AHP process. So to the process is we need to identify the problem. For the stage 1, establish structural hierarchies, and continue with the stage 2, which is establish pairwise comparison matrix. Next, stage 3, derive eigenvector and maximum eigenvalue. Stage 4, derive consistency index. And then we need to determine whether the CI is acceptable. What is CI? Later I will explain the more detail. Okay, if the CI is acceptable, we can continue this to the stage 4 to the stage 5, which is develop overall weight or priorities. If not, we need to repeat again on the stage 2 until the CI is acceptable. Okay, here is the explanation of AHP method. So here, as we can see, hierarchy of criteria of AHP method, we have 3 levels here: goal, criterion, or options, and alternative. Okay, for the goal, for the goal, the vision or mission to do and develop. For example, give to buy the perfect car. And then alternative. And then the stage 2 criteria. Criteria like the explanation of reason to choose the alternative. Such as price, types, size, design, color, and others. And then alternative. Alternative is the type of vision or mission. So what we aim to making the decision. For example, the choice that we have is Pro2, Proton, Toyota, Audi. That's for the decision making to buy perfect car. So in AHP method, we have the evaluation scale or weight, like I just mentioned before. So here we have 1 until 8 until 9 value intensity of important in AHP method. So we can see that the intensity of important 1, degree of preference equality, and this weight is equal, important to objective is equal. So this scale of AHP method, we need to choose correctly and wisely to get the best choice. Okay, here the sample calculation that I have calculated to show the application of AHP. So here we have the problem, we have the goal, factor, and the choice. Okay, so we need to make the table like this: criteria, A, B, C, D, and sum. Okay, the value that I have got for each criteria here is from the weight value that I have shown before, 1 until 9. So after we get all the value, we need to sum all the value. And next, we need to find the criteria weight. Okay, criteria weight is we can get the value of criteria weight by by dividing all the value here with the sum, and then we get the total of all the criteria and get the criteria weight. And next, for the weight sum value, to get this one, we need to multiply each value here with the criteria weight, and the total we can get the weight sum value, and then the ratio we can get from dividing weight sum value with criteria weight. So if we can complete all this table. Okay, next we can calculate the maximum of eigenvalue. So this is the 16.4 to 4 16.4025 we can get from the table, and divided by 4 because the alternative we have 4, and we get the 4.1007. And then we can calculate the consistency index CI. We can get from the maximum of eigenvalue minus by the n, the option, the number of option, and divide to number of option minus by 1, and get the 0.03358. And then the consistency ratio. This is the CR that I have mentioned before. The CR value must be acceptable to continue the AHP method. So here we get 3.731% of CR ratio, which is equal to 0.03. So this CR ratio less than 0.1. So we can continue to the next step. Okay, here the final result that I have conduct. So here we can see we just have factor A, B, and C. Factor D can be ignored because the percentage of the weight is higher, so we can ignore that. So here we get the adjusted weight. Okay, adjusted weight we can get based on criteria weight for the selected criteria but is only among of 3 factor only. So we get the 0.645, 0.1458, and 0.2092. So the choice X, Y, and Z that we have choose before. So the value here I get from the comparison value or weight. So this is just the sample. So we can assume that the best option for this is choice X, which is the composition weight is higher than the others, which is 49.95%. So if we other than that, I also use graphical user interface or GUI, and I choose Microsoft Excel to calculate all the data given. So the table that I have made before, I use Excel to get the best value for each option. Okay, next the expected result. Expected result that I assume for each material. Okay, for the ABS, I assume that the process to dispose, the best way to dispose the ABS material is incineration, because as we can see that uh, ABS does not. Okay, when ABS was burned, they doesn't produce the harmful toxic that can affect the air, the quality of air. So the next one is PLA. I choose landfill or composting because PLA have made from the the because PLA have made from biodegradable material like corn and sugarcane. So we can use landfill as the best end of life option. And the last one is pig. I think pig recycling is the best option for the pig, because pig is a very strong material, and it doesn't have any problem if we always recycling the product many times. So I think that's all from me. Have a nice day. Thank you.